In order to learn about the importance of muscle contractions, we're going to have to take a look inside the muscle. The first major component of contractions is the myosin head, which I draw kind of like a golf club. And the myosin head has some major factors on it. It has ADP bound, and it also has a little phosphate group. And when it's like this, it is in the cocked conformation, which means that it's unbound and it's kind of like in that shape. The chain is actin with little actin binding sites, which is important because that is the location that the myosin head will bind. The regulatory protein of tropomyosin usually blocks the binding of myosin to the actin when it is on the troponin. However, in the presence of calcium, the ions bind to troponin, causing a change which allows tropomyosin to move away, making the myosin head and the actin free to bind. Now that they are free to bind, the myosin head will add while the phosphate group actually leaves. The free phosphate group and the now bound myosin head allows the conformation to now change to be bent in order to move the actin and actually induce the contraction. At this point, ADP is actually ready to leave. And now that the myosin head actually has no ADP or phosphate group bound, free ATP will actually bind. Bound ATP now detaches the myosin head from the actin, and the conformation will no longer be rigor. The ATP being bound pushes the phosphate group into a different binding pocket, making it now ADP with a phosphate group also attached. This pushes it back into a cocked and unbound position where the nearby actin is no longer bound to the myosin head. This is a familiar look because now the cycle can start over. Now let's put everything we just learned into words. At first, the myosin head is cocked, ADP and phosphate groups are attached. It is unbound to the actin. And because the tropomyosin is no longer there because of a presence in calcium, it is ready to contract. So, as they are binding, the phosphate group is freed, and it is able to bind and change into a rigor or bent shape, and this causes the ADP to also leave. Now that the ADP is gone and so is the phosphate, ATP binds and causes the myosin head to unbind from the actin because of its instability. This returns it back to the cocked position. Finally, the ATP that is now bound returns to ADP as the phosphate group is put back into a different binding pocket. This cycle repeats, but please note, it is not repeating like exactly the same because every single step, another actin has moved over a spot, causing the actin to move, causing the muscle to contract. Thank you. I hope you enjoyed and maybe learned something.